Okay, today I have a very cool sketch. This is a variable night light. So we have a light sensing resistor right there, and as the light in the room gets darker, the light of the LED will get brighter. This is a light sensing resistor. It's not actually a sensor because there's just two pins. The way this works is as the light gets brighter, this variable resistor gets less resistance. So if we're going to use it as a sensor, what we have to do is it'll ultimately be wired up like the what was it, the temperature sensor from yesterday, or the temperature sensor from yesterday. But what we're going to do is the the first part of the light resistor will have the 5-volt source, just like the temperature sensor did. So that's going from the left pin to the red strip of the breadboard, and from there it's going to the 5-volt source on the Arduino. The second lead of the photo resistor is going to analog pin 0, and then from there we also have it going to a resistor, which is going to ground. So this photoresistor is 200 kiloohms, and I only have up to a 10 kiloohm resistor. So this is not maybe going to use the full accuracy that's available with this sensor, but it'll be good enough. Basically, when you have this setup, what you have is two resistors. So there's the photosensitive resistor and then the fixed resistor. The photosensitive resistor will change its value based on the light. So as more light enters the room, there is less resistance between the photoresistor and analog input 0, which means we're going to get a higher value. And as the room gets darker, there's going to be more resistance, so more of the 5 volts is going to go to ground. The LED is wired up just like before. This sketch doesn't use the RGB capabilities. We're just using the blue, but it was already in the breadboard, so I just stuck with it. And here's the code. So I just have my variables set up like before. The constants are setting the pins for the 3 colors of the LED. And then I have my value, which will be the value read into from the the analog read function. And then I have a variable to hold the value that we have to send to analog write. So the analog read function is going to read a value from 0 to 1023 because it's 10-bit resolution, but the analog write function can only go up to 255, 0 to 255. So we have to kind of convert those somehow. I did some testing, and the range that I can get with the sensor is between 149 and 995 for normal conditions in this room. So there's a couple functions we use to make that conversion. Let's see. Remember, iout is the variable where we're going to put the value that's going to analog write. So the first one is called map. Iout equals map, and then we give it the value read from the analog read function, and then our expected low and high values. So like I said, 149 and 995. And then we're going to give it the low and high values of what we want it to be mapped to. So that would be 0 and 225, but because we want the LED to get brighter as the room gets darker, I have 255 and 0 switched. So basically, whenever the analog read function reads the darkest light, which would be 149, that's going to set the iout to the highest value, which is 255, and the rest gets mapped correspondingly. If I have a value lower than 49 though, this map function is going to return a value that's above 255. That's just the way it works. And we don't want that because analog write cannot accept anything above 255. So this next function, constrain, takes the value returned by map and constrains it to a range of 0 to 255. So if it's below that, it'll just be 0, and if it's above that, it'll just be 255. Then I have my analog write, which I have the blue LED and the value from I out, and just a 100 millisecond delay. So pretty simple. This is our serial line, so we can see the values. Right now it's going in at about 797, and that's the value from analog read. So that's what that looks like. If I make the room darker, or actually just the sensor darker, then the LED is going to get brighter. So and we can see that on the serial line as well. Okay, that's darker, lower value, and brighter. And I'll show you what an upper limit would be for this. So I have a little flashlight. You can see the LED gets dimmer as the light gets brighter until eventually it's off completely. It's very fast. So if we look at our values here, whenever I hit the light right on the sensor, it's going above our top value of 995. So what the map function is doing at that point is it's setting it to a value below 0, and that's why we need the constrain. The constraint will put it back to 0 in that case.